Eris, the forgotten planet. When Michael Brown announced on February 28, 2004, the discovery of Sedna, an object believed to be nearly 2,000 kilometers large, orbiting between the Kuiper Belt and the innermost part of the Oort cloud, it seemed to everyone that the solar system had finally found its 10th planet. But the excitement didn't last very long. Sedna's diameter, however interesting, was soon reduced, and the count of the planets returned to be the same as before. Only 517 days passed, and on July 29, 2005, still Mike Brown announced the discovery of another large object, provisionally designated 2003 UB313. The estimated diameter was even 2,400 kilometers larger than Pluto's, and at that point, it seemed evident that the newcomer had all the qualifications to be crowned the 10th planet in the solar system, and the first one found beyond Pluto's orbit. Then it became known how the thing turned out. Not only was Eris, as it was later definitively called, never considered a planet, but Pluto also lost its planetary status, so that the planets, instead of increasing in number, even decreased from 9 to 8. Pluto, despite the downgrade, still remained on everyone's lips and in everyone's hearts, but Eris, having missed the train that would bring it notoriety, was soon almost forgotten, probably because it was considered just one of the many planetoids that would continue to be discovered in the Kuiper Belt in the future. Wrong prediction. Since 2005, in fact, nothing remotely comparable has been found in those remote regions, and Eris is still to this day the 9th most massive object to revolve around the Sun, the largest ever discovered since 1847, when Triton, Neptune's great moon, was found. In our opinion, Eris, on the other hand, deserves much more attention than it has received so far. To find something even bigger, we'll probably have to go as far as the Oort cloud, and perhaps even there we will not find an object more deserving of the title of planet. Let's keep its memory alive and get to know a little closer, shall we? Eris was discovered by astronomer Michael Brown and his colleague Chad Trujillo and David Rabinowitz on January 5, 2005, from images taken on October 21, 2003. Why the long delay? How come they didn't notice it sooner? Well, the reason is simple. The team had been systematically scanning the sky for the largest trans-Neptunian objects for several years, and had discovered several of them such as Quaoar, Orcus, and Sedna, for example using automatic search software that analyzed all the images taken. This dramatically accelerated the process of object discovery and allowed them to cover a wider region of the sky with their survey. However, the team had decided to have the software exclude all objects moving at an angular speed greater than 1.5 arcseconds per hour, not compatible with their presumed distance. To get an idea of how small such a shift is, keep in mind that the angular diameter of the moon is about 1800 arcseconds. But after manually discovering Sedna, a decidedly slow-moving object, Brown and his colleagues realized that the software would ignore its presence, so they decided to reanalyze all the images they had collected over the preceding months. And it was only in this way that they were able to find the object that would later become Eris, a trans-Neptunian that moved very slowly relative to the background stars and had thus been ignored during the first phase of analysis. The discovery was announced on July 29, 2005, the same day as Makemake's discovery, and only 2 days after Haumea's. Further observations were then made to determine the preliminary orbit of Eris, and on September 10, 2005, a subsequent analysis with the 10-meter Keck telescope in Hawaii also revealed the presence of a satellite later named Dysnomia. Dysnomia is about 700 kilometers in diameter, making it the second largest of the dwarf planet moons after Pluto's Charon, and it orbits Eris in nearly 16 days at a distance of 37,000 kilometers. At that point, Brown was holding an object of considerable diameter, accompanied even by a large moon. It seemed that nothing could stop Eris from finally claiming the title of 10th planet. But instead, all hell broke loose, and its discovery basically marked the beginning of the end for Pluto as well. During 2006, very sadly, Pluto and Eris were given the consolatory title of dwarf planet, a category that now also includes Ceres, Haumea, and Makemake. The orbit, very eccentric and inclined. Eris orbits the Sun in a very elliptical orbit with an orbital period of 559 years. In fact, its maximum distance from the Sun at aphelion is 98 AU, while its maximum at perihelion is only 38 AU. As it orbits the Sun, it completes one rotation every 25.9 hours. In the past, Eris arrived at perihelion around the year 1699 and at aphelion around 1977. In the future, it will return to perihelion around December 2257. Unlike the 8 planets whose orbits all lie roughly in the same plane as Earth's, Eris's orbit is highly inclined, about 44 degrees. This is why, despite its fair brightness, it has never been sighted before 2003. In fact, searches for large outer solar system objects tend to focus on the plane of the ecliptic, where most celestial bodies lie. Currently, Eris is the most distant object known in our solar system, if we disregard long-period comets. In theory, the detached object Sedna, which we met with discussing trans-Neptunian objects, is farther away from the Sun, having a semi-major axis of about 524 AU. However, currently Sedna is moving along a part of its orbit closer to the Sun at 84 AU and will arrive at perihelion around 2075-2076. Due to the high inclination of its orbit, Eris crosses only a few constellations of the traditional zodiac and is now in the constellation of Cetus. Hang on a sec, guys, before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. Size matters. Since its discovery, Eris's diameter has been gradually refined and reduced. In 2003, considering images of the Hubble Space Telescope, Eris's diameter was estimated to be 2,397 kilometers. For this, the classical approach of using distance to Eris, its albedo, and its apparent brightness was used. Albedo is a term in astronomy for the reflective power of a celestial body's surface. The maximum albedo is 1, when all incident light is reflected. The maximum albedo is 0, when no fraction of the light is reflected. The first case is that of a perfectly white object, the other of a perfectly black object. Eris has an estimated albedo of 0.96, higher than any other large body in the solar system except Saturn's 6th largest moon, Enceladus. Such high reflectivity is hypothesized to be due to surface ices, which are on the rise when, as at this time, Eris is in an orbital position far from the Sun. Comparing the diameter of Eris with that of Pluto, which at the time was estimated at 2,370 kilometers, Eris appeared to be slightly larger than Pluto, considering the best case of tolerances. It is very difficult to say which object is larger, Pluto or Eris. Pluto's atmosphere further complicates this assessment, which interferes with measurements of its solid surface. In 2007, the Spitzer Space Telescope was used to refine the dwarf planet's diameter, and the measurements indicated a diameter of 2,600 kilometers. In 2010, a rare event occurred, a stellar occultation. Never before had an occultation for such a distant object in our solar system been observed. The results cast serious doubts on previous measurements, in particular those of the Spitzer Space Telescope. Data obtained from the occultation during which Eris passed in front of a star indicated a diameter of only 2,326 kilometers. By contrast, in 2015, the New Horizons probe accurately measured Pluto's diameter to 2,376 kilometers. At present, then, barring other adjustments that are always possible, Pluto is confirmed as the largest dwarf planet, albeit by a very small margin compared to Eris. But mass also matters. Determining the mass of an isolated object like Eris with sufficient approximation is definitely difficult. Fortunately, the discovery of dysnomia has solved the problem at its root. In astronomy, it is indeed sufficient to know the orbital period of a satellite and its distance from the parent planet to easily determine the mass of the latter through Kepler's third law. A simple calculation then made it possible to find that the mass of Eris is 27% greater than that of Pluto, from which it followed that the density of Eris must be greater than that of Pluto. In fact, if we take into account the diameter determined during the stellar occultation, We obtained for Eris a density of 2.5 grams per cubic centimeter, significantly higher than Pluto's density of 1.75 grams per cubic centimeter. For comparison, the density of water is 1, while the average density of our planet is 5.5. Pluto and Eris therefore seem to have similar sizes but different densities. Their composition must therefore have been somewhat different. Eris is probably composed of much rockier and denser material than Pluto. Some astronomers suggest a composition of about 70% rock and 30% ice, but of course, these are only guesses. The surface and the atmosphere. The temperature of the surface as a result of a distance from the Sun that can vary considerably varies between minus 240 degrees and minus 216 degrees Celsius. No surface features can be observed directly from Earth, regardless of whether the telescopes are on the ground or in space. To know more, it is therefore necessary to proceed with indirect measurements, such as spectral analysis. On January 25, 2005, spectra were obtained at the 8 meters Gemini North Telescope in Hawaii. An analysis of the infrared spectrum revealed the presence of methane on the surface. Further analysis indicated abundances of carbon monoxide and nitrogen. This is similar to Pluto. When Eris approaches its perihelion, sublimation processes will be enforced, causing gases to escape from the surface and forming a thin atmosphere. Then, when Eris is departing from its perihelion, the surface temperature will continuously decrease until it reaches its maximum at the aphelion. The falling temperatures will enable resublimation, i.e., the gases in the atmosphere will freeze out and fall back onto the surface. Sublimation processes may be possible at these temperatures as methane is highly volatile. This, however, raises another question. How can we explain the observed abundances of methane if it is so volatile and sublimation can occur? Two possibilities are conceivable. First, Eris has always resided at such large distances to the Sun where it is cold enough not to trigger sublimation. Secondly, there may be an internal source for methane which replenishes the gas escaping the surface. No further details are known about Eris' surface. We can only observe that its color is different from Pluto and Triton. Whereas Pluto and Triton show a reddish color, Eris appears to be simply gray like many other objects in the Kuiper Belt. Future research. The extreme distance of Eris, which is the largest object that has not been visited by a spacecraft, combined with its small size, makes it difficult to observe the dwarf planet without powerful telescopes and advanced technology. One real possibility which could come to fruition soon is that Eris could be observed by the James Webb Space Telescope, which is expected to enter its operational phase soon. Regarding exploration by probes, in the 2010s there were multiple studies for follow-on missions to explore the Kuiper Belt, among which Eris was evaluated as a candidate. It was calculated that a flyby mission to Eris would take 25 years using a Jupiter gravity assist, based on launch dates of April 3, 2032 or April 7, 2044. Eris would be 92 or 90 AU from the Sun when the spacecraft arrives. But for now, these are just projects. To this day, Eris is still a distant dream for us, and probably it will still be for many years.